The Laplace transform of the step response of a system is given by this expression. The rise time is defined as the time taken for the response to go from 0.1 to 0.9 of its final value. The settling time is defined as the time taken for the response to reach 0.98 of its final value, and we have the time constant. So which of these is true? Okay, the situation that we're presented with is that we have a system that has a step response as an input. The output is some function, some signal, whose Laplace transform is written here in this expression. So we have something, we don't know exactly what type of output, but something that rises over time. And so the rise time is defined as the time it takes for the output to go from 0.1 of its final value to 0.9, and then we have then we have the time to reach 0.98, and you asked about the time constant. Okay, so the first thing we want to do is find out what this function actually is via the means of the inverse transform. The first thing that we do is we use the partial fraction expansion of this expression, which will be some constant over s, some constant over s plus 100. And in order to discover the values of a and b, we can use this simple trick here. We can multiply this entire expression, they are the same, by s. The effect will be to cancel the s in the denominator, leaving something that is multiplied by s plus a. Substituting 0 for s will cancel this part, leaving us with a. So we simply multiply this by s and then substitute 0. This gives us the value of a, which in this case will be 1. In order to find out the value of b, we can multiply this expression, which is equivalent to this one, by s plus 100. It will cancel out this denominator, leaving us with something that is multiplied by s plus 100 plus b. Substituting minus 100 for s will simply reveal the value of b, which in this case is minus 1. So this is achieved by first multiplying this by s plus 100 and substituting minus 100 for s. Okay, this is the partial fraction expansion of y. The inverse of this is 1 over s is simply the step function, and this is a decaying exponential. So this would be the inverse Laplace transform. The time constant is simply 1 over this value. It is 1 over 100. It is 0.01. We can immediately rule out these two answers, C and D. We're left with either A or B. The time of reaching 0.98 of the final value is known to be around 4 times the time constant, in this case 0.04, leaving us with only solution A. Okay, ruling out B, this is only solution A, 0.04. This concludes the answer to this question.